Hey guys, welcome back to my channel and this is Varun Tahin. So till now we have seen how do we do one sample mean test and two sample mean test for the paired and unpaired data. And what we have observed there is that in these cases or tests, the data from the sample is always numeric in nature. But now the question arises, what would you do if the data is categorical in nature, that is in the fashion of 1 or 0 or yes and no? Let's take a closer look how do we handle such situations in this session. So let's take an example to understand such data and situation better. Let's say that if you are comparing the effectiveness of two drugs, you would define the desired outcome of the drug as a success or a failure. So you would take a sample of the patient who consumed the new drug and record the number of success and compare it with the successes in the other sample who consumed the standard drug. Now let's take the example we were working with previously of commute time, and this time let's say we have categorical data with us which says how many people take more than 35 minutes or less than equal to 35 minutes on a particular day, and we collect this data for the other day as well with a similar filter. So I have this sheet stored in a GitHub repo which is already shared with you guys in the previous session. So when I click this link, it will actually redirect me to the same repo, and in that repo we have to download the two sample proportion test.xls, and once you open it you will see that it will have data in two new columns, which is categorical data for day 1 and categorical data for day 2. Now you will observe that in these columns only values 0 and 1 are present. So this signifies true and false situation, that is we are dividing the data with a condition. If the commute time is less than equals to 35, we represent that as 0, and if it is greater than 35, then we are representing that value as 1 or true. So in that manner we are dividing the data into categories. That is, we are dividing people who are taking more than 35 minutes to commute and people who are taking less than or equal to 35 minutes to commute. Now you can also confirm the various formulas by double clicking on the various cells which are marked as categorical data. Okay, so here you can see that we are assigning 1 to the cell if B2's value, that is this value which is 27, is greater than 35, otherwise we will assign 0 to it. So as 27 is less than 35, we will assign 0, and therefore you are seeing here 0, and the identical formula is applied in every cell in this column. Now the second thing to observe here is when you select this column, right, you can see that 15 out of 32 people have commute time over 35 and above. That is approximately 46% of the people have commute time of 35 and above minutes on the day 1. Whereas in the day 2, we can observe that 20 out of 32 people have a commute time of 35 and above minutes. That is approximately 63% of the people. So hence there is a role of proportion here in the samples, and therefore what we conduct here is not a sample mean test but a proportion test instead. So to conduct this test, we cannot use the data analysis add-on that we used previously, but instead we would need Excelstat, which is not usually comes along with the Excel. So for this you have to either go to Google and type Excelstat or go to the link here that I'll be sharing with you guys and download this tool. Okay, so when you go here, it will redirect you to excelstat.com/en, wherein you can try this as a trial version. Okay, so this is a paid tool and you can use it for 14 days as a trial version. So when I click try now, it will give you an option of selecting the tool you want, and we would try the Excelstat. And on this page you can download the Excelstat for your OS. So I have Windows and I have downloaded it already. Okay, so let's now install this. So I'll just continue. So I'll just ignore this warning which comes here. Click OK and continue. And I do not want R, so I am not checking this checkbox. Just click install. Okay, now it says that Excelstat was installed successfully. So I'll just run this. Okay, now when I come to my workbook, that is my Excel, it is asking for a trial key or entering an Excelstat license key. Okay, so what I do is just request a trial key and continue, and then specify my details over here. So I say student and country, I'll say India. Just agree to this and continue. So I'll just accept this and say yes. Now this gives us a message that Excelstat cannot activate the license operation due to Windows protection. So in case you are facing this issue, it is also guiding us to close the Microsoft Excel and open Excelstat license manager from the Windows menu. Okay, so we will do this. Okay, so I'll say okay and then close this, or it is asking us to close this. Now I'll say yes. I'll just close this screen as well and then close this Excel. Now I will go to my start and type here Excelstat. Okay, so you are seeing here Excelstat license manager. So I'll just click this and then say activate license. So it's asking for a license key, and what we need to do is we need to search our email for that license key. So I have got the license key in my email and I have pasted it here. Okay, now what we have to do is we have to do an automatic online activation. So I'll just paste the key here and click on activate license. So it is asking me to close the Microsoft Excel before this operation. Okay, so I'll go here and close it. I'll not save it and then click on OK and again click on activate license. Okay, so it says license has been activated. Okay, and now I'll just close this window. Then what I do is I open the Excel again. So you will see this Excel now, and in this Excel you will notice that Excelstat started coming at the top of the Excel worksheet, right? So I'll go to this tab, click on start Excelstat, and then I will be redirected to some window where it will ask me my preferences, but generally I close this window. Okay, and then go to the options of parametric tests and select test for two proportions here. Okay, now here it will ask for the data format. So generally for me it is like frequencies because it is easier to give. So I've selected frequency, and we have seen that frequency of occurrence of 1 in the categorical data for day 1 has been 15 out of the sample size, which is 32. Okay, so we will give 15 and 32 here, and then for the frequency 2 I will say 20 out of 32. Okay, so this is the observation that I had already. So I have given this. So in the output you can either give range, sheet or workbook that we have seen previously also. So this time let's go with range. So this will give you an option of selection of various cells in this worksheet itself, which will be outputting your results. So I'll just click this button and then select some range over here. Okay, so just be very careful that you don't overwrite the original data. Okay, so I'm just clicking the empty cells over here. Now it has selected, so I'll just press this button. Then what I do next is go to options and keep this as a default one, because we are hypothesizing the difference of proportion 1 and 2 to be 0. Okay, so as the name suggests, this is the alternate hypothesis, so it should be not equals to D or not equals to 0, and the rest remains the same, that is hypothesis difference is 0 and significance level is 5%. Then I'll just click on OK. So you'll get all these statistics over here. Now you will notice that you will get too many figures and statistics over here. So the first thing to check over here is whether our inputs are correct or not. Okay, so we can see that frequency is coming as 15 with a sample size of 32, and frequency 2 is 20 with the sample size of 32, and hypothesized difference is 0 and the significance level is 5%. Okay, so this also gives you a flexibility to rerun the test. So this button, if you click, it will rerun the test and you can verify the test again. Now coming to the interpretation part, you can clearly see the p-value is 0.309 and alpha is 0.050, which is 5%. And from the previous videos you can conclude that p-value is greater than the alpha, therefore we cannot reject the null hypothesis, and that is what written in the interpretation also as a text. So it will give you a kind of textual understanding of what this table means. So it says that null hypothesis is the difference between the proportion is equal to 0. The alternate hypothesis is the difference between the proportion is different from 0, and the result is as the computed p-value is greater than the significance value, that is 0.05, one cannot reject the null hypothesis. So now that we have seen the proportion test, let's see another form of testing known as A/B testing. So you might have come across A/B testing word if you are from a technical background. So A/B testing is one of the ways which you can use to improve the user's experience on the website. So let's learn about A/B testing, as to what is A/B testing and why it is needed. So let's start with a poll. Let's look at two versions of a dialog box that you are seeing on the screen, where customer has to enter the details on a real estate seller site. Which one do you think attracted more customer to fill the form? Can you just pause the video and rethink? You will be surprised to know that option A had drawn most of the customers than the option B. The reason is that it asked lesser details to be filled, unlike the option B. So this example illustrated the importance of testing on different version of the website, where you use data-driven decision making. So now that we have seen what A/B testing means, let's define it formally. So the testing of different variation of the website is done like this. So the population is divided into two, with 50% shown with the variation A of the website and the other 50% shown only the variation B. And then at last we will see the conversion rates of each of the variation accessing the form filled by the population. So this way we can identify which variation is serving better for a particular feature. So A/B testing helps improving the website experience, which in turn improves sales and revenue of the company. Now, while developing an e-commerce website, there could be different opinions about the choices of various elements, such as the shape of the buttons, the text on the call to action buttons, the color of various UI elements, the copy of the website, or numerous other such things. Often the choice of the elements is very subjective and is difficult to predict which option would perform better. So to resolve such conflicts, you can use A/B testing. So A/B testing provides a way for you to test two different versions of the same element and see which one performs better. So I have given several links. You can refer about A/B testing from these links if you want to know more about it. Then there is one link that will give you a comprehensive case studies and application of A/B testing in real world scenarios. And there are various other tools to conduct the A/B testing, like R and other testing tools such as Optimizely. So you can go through this also in your free time. Now you might be thinking why we have spoken about two sample proportion test. Actually, A/B testing is a variation of two sample proportion test, and therefore two sample proportion test is used to do A/B testing. Okay, now we have downloaded this Excel, right? This has one sheet for A/B testing data. So now what we do is we will test it using two sample proportion tests. So what we have is a old feature or a control group, which is either accepted or rejected by a certain group of people. Okay, and then we have an experimental group or a variable group, which is a new feature and is accepted or rejected via some group of people. And what we do is we need to check, that is, whether the new feature is attracting more customers or the old feature is attracting more customers. So let's look at the proportion as of now. So the old feature has 1 in 618 cells out of 2620 people, that is 23.5%, and the variable group or the new feature has 1 in 601 cells out of the 2380 total population, that is 25.2%. Now looking at this, we can say that new feature might be probably more suitable for our website, but we cannot directly conclude this, and we have to do some sort of two sample proportion test to confirm this. So what we do is, again we will go to the parametric test and select the test for two proportions, and we will select the frequency as we have done before, and for the frequency one we will select 618 out of the sample 2620, and in frequency 2 we will give 601 out of 2380. Then for the range we will select, and for the range we will select some empty cells here. Then we'll go to options and select proportion 1 minus proportion 2 is less than D. That means that we are hypothesizing the alternate hypothesis that proportion 2 is better, that is the feature 2 is better than the feature 1, and hence if we subtract the proportion 1 from proportion 2 we will get negative as an answer, that is less than 0. Okay, now hypothesized difference will be 0 and the significance level will be defaultly 5%. So we'll click OK here and just verify the inputs first. So 618 was the frequency 1, sample size was 2620, 601 was frequency 2, 2380 was the sample size 2 with hypothesized difference as 0 and significance level of 5. So when we go down we will see the p-value which is 0.091, which is greater than the alpha, and hence we say that we cannot reject the null hypothesis because p-value is greater than the significance level. That means that the original feature is better than the new feature. So guys, you remember that we have calculated the proportion for old feature as 23.5 and for the new feature as 25.2, but irrespective of the proportions, we have got the result from the statistics that the old feature is better than the new one. And if you want to be really sure that these statistics are correct, you have to collect additional data or do some more A/B testing on additional population. Now we can perform hypothesis testing through Python also using the stats module from Scipy library. So we can conduct one sample test, two sample tests, as well as pair test from the same library. So the one sample test is to test if the population mean of the data is likely to be equal to a given value. So for that, scipy.stats.ttest_1sam function is used, where you can equate the value that you're looking for. Then for the two sample test, we'll test for the difference across the population, and ttest.ind function is used there, and two columns are passed. Then pair test also are possible, where repeated measurement on the same individuals are done, and ttest_rel function is used with the two columns. So that will be all for today guys, and this also completes major topics I planned for statistics. Now from the next session I will be covering the mathematics concepts required for data science. Let me know how did you find this video by commenting and sharing among your friends if you liked it. Please don't forget to subscribe my channel if you haven't already, and also hit the bell icon, as it will give you updates regarding the upcoming content which is coming soon. You guys have been excellent support and encouragement for me to make more videos on data science topics. I will soon come up with exciting discussions and live sessions in the coming weeks. So also stay tuned. Until then, take care and happy learning. Cheers.